green sand is made mainly of two components. First is silicium, or well, silice, which is also known as common sand, and bentonite. I don't know the name in English. Sorry. Well, the bentonite gives a mix like plasticity in order for it to stay in the shape that you want, and the sand gives it thermal resistance and allows it to reach all the small places that have the mold.
A razor is a receiver of material that fits the mold in order to present mistake as piper or cavities, and the crisol is where you put the metal to melt it, and it must resist great temperatures.
Now, some of the disadvantages of sand casting is that this process needs a mold, and for each piece that we create, the mold is destroyed. So this makes the process slower because making the mold do take extra time. Also, the final piece can have several pores, and if the mold isn't set correctly, it may have defects like cavities or pipes. Also, the mechanical properties may decrease, and this process has to be done delicately. Now, the advantages are that as we create the mold, we can make the mold for any piece we want with the specifications that we want, and this makes pieces precise pieces. Also, this process tolerates high temperatures and is the most used. Some of the tolerance that sand casting needs are the first one is the shrinking tolerance, because when the piece gets cold, the size reduces. Also, the finishing tolerance for the final polished, the final piece, so it gets better, and we have to perfect the defects, the little defects.
How can we avoid cavities or piping in our material? So first of all, we need to consider that the material must cool down fully before another part of the material is entered. So for this, we need to make sure that the material we use for the mold is one that has a good thermal diffusion, so that part of the heat won't be trapped and one part will cool first than the other. Another is to make sure that the entrance for the melted material is near the part where you will pour the material, so that it doesn't have time to solidify before even entering the mold.
There are two ways of degassing a molten metal. First is by simply mixing the material with a steel bar or something in order to the hydrogen to come out of the metal. Also, to use a chlorine cylinder to take out all the impurities on the material. More modern degassing systems use diffusion of nitrogen into the material. The nitrogen creates bubble in the material, which rises and carries with it all the hydrogen and impurities. In order to this process to work, the nitrogen has to be in small bubbles and to be equally dispersed throughout all the material in order to be effective. And last is almost the same as a nitrogen injection, but the injection is rotating in order to have a more uniform distribution of the nitrogen bubbles.
In a frame, the desired piece is placed and covered with sand, and then it's compacted. The same is repeated for the other side of the piece, but with metal tubes. That is where the metal is introduced, and then both sides are molted and the metal is poured.
When we talk about a heart in casting, we talk about a piece that goes in the middle or in some part of the mold, in order for that part to don't melt with metal. For example, if you have a cube and you want that it has a cylinder in the middle, you put a heart with the shape of a cylinder in the middle of the cube. these hearts may require to have some pivot points for them to don't move while the metal cools down.
So why was it important to degas? Because in our process of casting, the melted aluminium has two types of impurities. One is dissolved hydrogen, and the other are other solid impurities that are non-metallic. So the hydrogen will attempt to leave the material once it starts to cool down, but this will leave unwanted impurities. Sandcasting is a very good process for melting metal and getting a product because it allows us to obtain a finished product that has a lot of precision and has great tolerance measures, but it's also not that expensive because you only use your green sand. The only disadvantage of it is that it includes a lot of hard labor.
In conclusion, this process may be slower than other processes, but it gives, for example, if you want to make only one time, you want to do it one time only, it's very useful because it's very precise. But you have to be qualified to make a mold because if not, you will make it worse.
Sandcasting is very useful and I think also very cheap because the material you use is just a few, like green sand, but you need to be careful so that it works. But I don't think I would use it to a product of series because it's only one mold.
In conclusion, this process is effective. However, me as an industrial engineer isn't convenient for a company because of the cost that this implies, because that is just one mold that destroys. However, talking about the process itself, it's a good process. It gives us good results, and now with this process I can compare with another process, so I can choose the better one for a company.